Coming up, we are going to talk about Azure Arc-enabled data services and some of the exciting features that Azure Arc brings to the on-premises and multi-cloud environments. I'm here with Dinakar, Principal Program Manager for the Azure Arc-enabled data services team. Hi, Dinakar. How are you doing?
Fantastic, Thomas. How are you?
I'm doing great and excited to have you here today. So today we're going to talk about some exciting new features for Azure Arc-enabled data services with the business critical tier. And all these tiers are, all these features are directly supporting business continuity.
That is right.
So great. So before we actually dive in, Dinakar, can you tell us a little bit more and give us a quick overview on the differences between the Azure Arc general purpose offering and the business critical offering?
Yeah, so there are certain capabilities that are common across both the service tiers and certain capabilities that are available only in the business critical service tier. You can think of general purpose as equivalent to the standard edition of SQL Server and business critical as the enterprise edition of SQL Server. Features that are common across are things like automatic backups and restore, provisioning, deprovisioning, scale up, scale down, disaster recovery, etc. And features that are differentiated in the business critical service tier include enterprise edition level engine features, no limits on memory and CPU allocation, the built-in high availability on top of what is already available from Kubernetes. And then you can also configure some of your secondary replicas for your read workloads.
No, that makes a lot of sense. And you already mentioned a couple of these features we're going to talk about today, which are all related to business continuity. Can you help me understand a little bit more about the features we were talking about and how they help with business continuity and what does actually mean?
In this case, we are referring to a few key features of Azure Arc-enabled data services that allow businesses to retain continuity regardless of any disruptions that could otherwise disrupt your critical business functions. Specifically, today we'll cover high availability, disaster recovery, and automatic backups and restore.
Okay.
Let's start with the feature that is available in both general purpose and business critical service tier, which is the automatic backups and restore.
Okay, no, that's great. So let's dive in.
The point-in-time restore feature is a built-in capability with Azure Arc-enabled SQL MI. This feature is available in both the service tiers. When you create a SQL Managed Instance, the backups are automatically taken care of for you. These backups are retained for 7 days as a default and can be taken as frequently as every 5 minutes. Customers can change the retention period anywhere from 0 to 35 days. And when it's time to restore, customers can simply specify the point in time to which they want to restore to, and the backup and the restore service takes care of all the backups that are required to restore to that point in time. Optionally, long-term retention data can also be sent to Azure storage or stored on premises for remote storage.
This is fantastic. So we're actually building this, what customers already know when they run this stuff in Azure, but they can now also leverage that obviously on premises or even at other cloud providers.
That is right. This provides a baseline of disaster recovery for our general purpose users as well as business critical users.
Okay, now business, that's obviously very important for a lot of the organizations out there. Now, you mentioned this. Can you also show a little bit of these new features?
Yes, let's take a look. In this demo, I will walk through the point-in-time restore feature that is a built-in capability in Azure Arc-enabled SQL Managed Instance. I already have an environment set up with a data controller already created on my Azure Kubernetes cluster. So I will proceed with creating the SQL Managed Instance. Now I have already set the environment variables here, so I will be prompted for SQL authentication credentials. Let me enter the values. So what's happening here is that the SQL Managed Instance will get created in the namespace that is associated with my custom location. One important point to note here is the storage class requirement for backups. A read-write many access mode capable storage class is a requirement for backup storage class. In my sample command, you can see that I'm using a storage class called Azure File for my backups. In Azure, on AKS, Azure File is a storage class that supports read-write-many access mode. For my data and logs, I will use the Managed Premium Storage class. Now, while this SQLMI is getting created, let's switch to another SQLMI that I already have on the same data controller. I can run the following command to get a list of all the SQL managed instances that I have on my data controller. kubectl get SQLMI -A. This will list all the SQL instances. As you can see, I have SQL Demo 1 that is already installed, and SQL Demo 2 is in the process of getting created. I'm going to use the primary endpoint listed here for SQL Demo 1 to connect to this instance from my SQL Management Studio, which is here. You can see that I have a sample database called AdventureWorks 2019 that I created yesterday, so there are some backups going on in the background. I don't have any other user databases at the moment. If I do a quick refresh, you can see that AdventureWorks 2019 is the only user database I have. Let's switch back to the terminal and continue with the restore command. First, I will run the restore command using the dry run flag. And I will provide some values for my source and destination databases. The -- time parameter here is optional. If I don't provide any value, it will restore to the latest point in time. The output of this -- dry run is a validation of my command. It tells me whether or not my restore command will succeed without actually running it. In this case, it looks like all my parameters are correct. Let me grab the time from this output so I can run the actual restore command without the dry run flag this time. Let's give this a couple of minutes to complete the restore. While this restore is running, I also want to show you how you can do the same thing from Azure Data Studio. In Azure Data Studio, make sure you have the extension called Azure Arc that gives you the ability to connect and manage Azure Arc resources. First, I will connect to my Azure Arc data controller. I need to provide the namespace where my data controller is created. And it will use the cluster context, which is the current cluster context. In this case, it is AKS Fabricam, which is correct. And then I click on connect. After it connects to my data controller, I can expand this tab here, and it will go fetch the list of SQL instances that I have on this data controller. You can see that SQL Demo 2 is probably created by now. I'm going to connect to the dashboard by right-clicking on the database instance and click on Manage. This will pull up the dashboard for SQL Managed Instance. Here, I have a tab called Backups. This tab lists all the databases that I have on this instance and also the backup window for each of these databases. Let me connect to this server. Once the dashboard is connected, you can see that I have AdventureWorks 2019 and also the new database that already restored. So in this window, it shows me the earliest point in time and the latest point in time for each of these databases. I can click on this restore button here, and it will pull a blade on the right side where I will need to enter the input for the source and destination information. And once I provide all that information, I can click on the restore button here to restore this backups to a new database. Let's switch back to the terminal and check on the status of our original restore command. So as you can see, the restore actually completed. Now let's switch to the SQL Management Studio and check this new database is accessible. Let me refresh the databases tab here. And you can see that I have a new database called AdventureWorks 2022 that we just restored. So there it is, point-in-time restore feature in SQL Management Studio. This concludes the demo of point-in-time restore feature in Azure Arc enabled SQL Managed Instance.
That was great. So it's great that customer can deploy a instance of SQL and get automatic backups out of the box. Now, let's have a look at the high availability features that are part of the business critical tier.
With business critical service tier, the high availability feature of Azure Arc enabled SQL Managed Instance allows you to deploy 3 replicas or 3 copies of your SQL instance for increased availability. In the event of a node or a pod failure, the HA orchestrator pod will promote a secondary replica to become the new primary and automatically redirect your application connections to this new primary. This will enable your applications to continue working without any manual intervention. Once the failed node or pod is back up and running, the replica is added back into the availability group and data is synchronized to bring it back up to speed with the remaining replicas.
Oh, this is awesome. So customers are really getting true high availability with the business critical tier.
Yes, that's right. And beyond that, all the 3 replicas are kept in sync. What this means is that each of these 3 instances are identical. So your applications are always reading the most recent data. Another differentiating capability of the business critical service tier is the ability to run read workloads off of your secondary instances by configuring the readable secondaries property during deployment.
That's incredible. Do you have another demos to show us how you would set this up, for example?
Yes, let's take a look. In this demo, I will cover the built-in high availability feature in Azure Arc enabled SQL Managed Instance. I'm going to be using the business critical service tier that has the contained availability groups built in out of the box. This is in addition to the high availability that Kubernetes already provides. For my demo environment, I have my Azure Arc data controller installed on Azure Kubernetes cluster. First, I will create a SQL Managed Instance with the business critical service tier, and I will specify 3 replicas. The command for that would be as follows. Let me enter the credentials for the SQL authentication when it prompts for the credentials. Let me highlight a few things here. In this case, I'm using the indirect mode deployment. This means that the data controller was deployed in an indirect connectivity mode. Because the connectivity mode is indirect, I'm running my commands directly against the Kubernetes cluster, as opposed to going through the Azure for the direct connectivity mode. Instead of custom location and resource group, I need to provide the --k8s namespace parameter and also use the --use k8s flag. Note that I'm specifying Azure file for my backups here. The Azure file storage class in Azure Kubernetes Service supports read-write many access mode that is required for the backup storage class. I'm also specifying business critical as the value for --tier parameter. And finally, I'm also specifying a value of 3 for the number of replicas that I want to be created. When this deployment completes, I will have 3 replicas of Arc SQL Managed Instances deployed, each with its own storage. But they will all use a shared storage class, the Azure File storage class for backups. All the 3 replicas will be in synchronous mode, which is the default mode. We can verify that from the availability groups dashboard in SQL Server Management Studio after the deployment completes. While this deployment is ongoing, let's explore what's happening under the hood. Let's switch to another terminal window first. If I run the command kubectl get pods -n and provide the name of the namespace, which is the arc ns here, I can see all the pods in my namespace. You can see that the SQL Demo 2 pods are getting deployed. There is also a SQL Demo 2-HA pod that is getting deployed. This is the availability group's orchestrator pod. The orchestrator in this pod keeps track of the health of the individual replicas and decides which of the replicas is primary at any given time. It also coordinates to promote the secondary replica to primary role in the event of the primary replica going down for whatever reason. While this deployment is going on, let me also show you how you can deploy the SQL Managed Instance from Azure Portal. From Azure Portal, there is a search bar here at the top. I'm going to look for SQL Managed Instances. And I can see two results. There's SQL Managed Instances, which is the Azure Arc, which is the Azure SQL MI, and there is the SQL Managed Instances with -Azure Arc at the end. This is the one that I want. And I'm going to click on the Create button. This will pull up the standard Create resource in Azure. So I'm going to select a subscription that I want to use and the resource group that I'm going to deploy this service in. Then I will enter the name for the SQL instance. And I'm going to pick the custom location that is associated with the namespace where I want the SQL instance to be created. Now, one critical thing here to note is the compute and storage piece. When I click on this compute and storage, I see another settings page. This is where I get to select the service tier. Right now, it defaults to general purpose, which is similar to the standard edition of SQL Server, which has the limits of 24 cores and 128 gigs of RAM. I want to create the business critical service tier. In this case, there is no limit on the cores and memory. I can also choose to create this in a development only mode, which means I will not be charged for my instance. And for my high availability, I have two options. I can either create it in 2 replicas mode or 3 replicas mode. And once I choose the number of replicas, I will also select the storage class for my backups. In this case, I want to use Azure File. Once I select all these options, I can click Apply and come back to the main window. Here, I also get to choose my service type. My options are node port and load balancer. Generally, load balancer is the preferred way to deploy. And then I can enter my administrator account credentials. And once I enter all that information, I can go to review and create. Let's switch back to the terminal to see the status of the previous deployment. I'm going to use the primary endpoint listed here to connect to the SQL Managed Instance. And we will look at the availability group dashboard in SQL Management Studio. Going to connect to this endpoint here. Going to expand the always on high availability groups node and check the dashboard. You can see that I have 3 replicas here. SQL Demo 1-0, -1, and -2. And the SQL Demo 1-0 is the primary replica. And all the replicas are in synchronous mode. And currently there is no data loss. And my availability group looks in a healthy state. This concludes the demo of the built-in high availability for the business critical service tier in Azure Arc SQL Managed Instance.
That's incredible and super easy to set up. Now, you also mentioned disaster recovery.
Yes, so in the theme of business continuity, let's talk about disaster recovery. Typically, you have a primary data center that has a Kubernetes cluster with Azure Arc enabled SQL Managed Instance running in either general purpose or the business critical service tier. Then you have a secondary data center that also has another Kubernetes cluster where you also have another Arc enabled SQL Managed Instance running in the same service tier as your primary data center. Customers can then set up instance failover groups between these two instances, and data is automatically sent from the primary instance in the primary data center to the primary instance in the secondary data center.
Oh, that's awesome. Can you show us a demo on this?
Yes, let's take a look. In this demo, I will cover the built-in disaster recovery feature called Azure Failover Groups in Azure Arc enabled SQL Managed Instance. The technology behind this disaster recovery feature is backed by distributed availability groups in SQL Server. For my demo environment, I have my Azure Arc data controller already created on an Azure Kubernetes cluster. I also have two SQL instances that I have pre-created. Typically, in a disaster recovery scenario, the instances are in two separate data centers that are geographically separated. For the purposes of this demo, both of my instances are in the same cluster. Also, when I create the instance in the disaster recovery data center, I specify a special parameter called license type and set the value to disaster recovery to indicate that the SQL instance will be a DR instance. Let's look at how the command will look like. If you notice in this command, there is a parameter called license type, and the value is disaster recovery. You need to make sure you set this property called license type to disaster recovery when you set up your DR SQL instance. Now let's go and verify if my SQL instances are properly created. I'm going to run this command called kubectl get SQL -A. This will give me a list of all the SQL instances I have in my Kubernetes cluster. Once I have my primary and geo-secondary instances created, the first thing I need to do to set up Azure Failover groups between the two instances is to get the mirroring certificate for each of these instances and put them in a shared location where both the instances can access each other's certificate files. Let's go ahead and do that. So I have the command to generate the mirroring certificate for my primary SQL instance. It looks like my certificate file has been created successfully. I'm going to run the same command for my second instance as well. And my certificate file for the second instance is also created. Let's go and check the folder to see if these certificate files are created. So I have a folder called dr certs. That's where we are writing the certificate files to. And I can see that both the files have been successfully created. The next step is to retrieve the mirroring endpoint for each of these instances. To get the mirroring endpoints for each of these instances, I can run a command called kubectl describe on the instance to get the information. Let's run the command for the primary instance. In this case, the mirroring endpoint is indicated in the output here. I'm going to copy this information out. I'm going to run the same command for my second instance as well. Now that I have the mirroring certificate and the mirroring endpoint for each of the instances, the final step is to create the failover group between the two instances by running the create command under instance failover group arc subgroup on both the sides. Let's take a look at the command. The command group instance failover group -arc is under AZ SQL. The command to create the failover groups is under instance failover group arc create. Let's go and check that. So as you can see, the create, delete, show, and update commands for setting up failover groups are under the AZ SQL instance failover groups -arc command group. I'm going to use the create command to create the failover group on the primary instance first. This will create a custom resource on the primary. When I'm creating the failover group custom resource on the primary, I also need the mirroring endpoint and the mirroring certificate of the secondary instance. So my command to create the failover group on the primary will look something like this. On the primary instance, this is the command I'm going to use to create the failover group custom resource. The parameters I have here are shared name, This is the shared name that will be used on both the failover group create commands. I also have a name for my custom resource, and I'm going to provide the name of the primary SQL instance and set its role to primary. And I also provide the partner instance name, the URL for the mirroring URL for the partner instance, and the location where the certificate file for that partner instance is located. And then I also provide the Kubernetes namespace where the primary instance is located. Let's go ahead and run this command. So when I run this command, it deploys the custom resource called inst1cr in the namespace fabricam-ns. Now on the secondary, I'm going to create a similar failover group custom resource and point it to the primary instance using the mirroring endpoint and the mirroring URL for the primary instance. In this case, you can see that the endpoint and the certificate files that are listed are for the secondary instance. Now I'm going to do the reverse of it on the secondary instance. Looks like my custom resource on the secondary instance is created as well. Let's go ahead and check if the failover groups are properly created by running this command called kubectl get failover groups -A. This will list all the failover group custom resources I have. In this case, because both my instances are in the same cluster, I'm going to see two custom resources. Instance 1 custom resource and instance 2 custom resource. So I have successfully created a failover group between these two instances. Now let's connect to the primary instance endpoint from SQL Server Management Studio to verify this setup. I'm going to run the kubectl get SQL mi -A to get the endpoint for the primary instance to which I'm going to connect to. I'm going to copy this and connect to that instance in my Management Studio. In my SQL Management Studio, once I'm connected to that instance, I can expand on the always-on high availability node and check that I have a distributed availability group. And I can see that my replicas are SQL Instance 1, which is the primary instance, and SQL Instance 2, which is the secondary instance in the geosecondary data center. But once I'm connected to this instance, I can also run a few queries to get the replicas and their available states. For example, select star from sys.dm_hadr_availability_replica_states gives me a list of the availability replicas and their current states. I can also run another query, another DMB. Select star from sys.availability_replicas. That also gives me more information about the replicas. In this demo, you can see that I have 3 high availability replicas. This is the availability group within the data center. And then I also have distributed availability groups, which is going across the data centers. This concludes the demo of Azure Failover Groups, which is a built-in disaster recovery feature in Azure Arc enabled SQL Managed Instance.
Thank you, Didakar. These business continuity features are really impressive, especially for customers who haven't been able to take advantage of Azure before, especially like when they needed to run their services on premises or in multi-cloud environments. Now, Azure Arc obviously supports 2 different modes. They support a direct connected mode, so when a customer has a stable direct connection to Azure and can leverage that. But many of these customers, they don't have a stable connection, or they don't have a permanent connection where they can reach Azure at every time. So can you tell us a little bit more about how these 2 modes work?
Sure. We have 2 connectivity modes today, direct and indirect. All the capabilities that we discussed today are available in both the modes. The direct connectivity mode unlocks a few additional capabilities. For example, customers can deploy and manage Azure Arc resources in their Kubernetes cluster directly from Azure Portal. Customers can also use Azure Arc in the direct connectivity mode. These customers can also upload their metrics and logs to Azure Metrics and Azure Log Analytics, and they can get notified from Azure via alerts for certain events.
This has been great. Thank you very much, Didakar. Now we have one more video coming up, which covers the key security features and the benefits of Azure Arc-enabled data services business critical tier. In the meantime, if our viewers want to learn more about these new features, where do they go?
Yes, you can check out our documentation page at aka.ms arc data docs, or our Microsoft Learn content at aka.ms arc data learn. Or you can actually access a trial version and explore what Azure Arc has to offer at aka.ms arc trial.
Awesome. Thank you very much, everyone, for watching. If you want to learn more about hybrid and multi-cloud architectures, check out our Cloud Adoption Framework and our Azure Architecture Center.